I'm going to assume we're live and ready to go. So I'm going to work through my slides here, and hopefully everyone can hear and see okay. And I'll do my best to work through these as fast as we can, because I know we're at the end of the afternoon here. So, so Edward Tufte is one of the leading thought leaders in the space of data visualization and communicating with data. And quote from Edward Tufte is, at their best, graphics are instruments for reasoning about quantitative information. Often the most effective way to describe, explore, and summarize a set of numbers is to look at pictures of those numbers. And so we're going to talk a little bit about data visualization and what makes good data visualization. I'm actually going to start out with a story that I first heard back in business school. It was told to me by a professor there, and is a recount of basically Edward Tufte's view on this subject. So back in the 1980s, there was a space shuttle mission that involved a search for a school teacher. And there was a lot of promotion around it to send a school teacher into space. The teacher that they had to search, and this a lot of applications for this opportunity, and the teacher they finally selected was Krista McCullough. And I remember this. I was a young boy. It sticks with me very poignantly. We're watching this space shuttle launch, and soon into the mission, the shuttle exploded. It was a very tragic event, and it's something that sticks in my mind today. It's a very clear image of what happened that day. But what happened? What led to this disaster? Well, on review, they determined that one of the O-rings in the solid rocket boosters for the shuttle failed, blew through, and ignited the liquid fuel tank underneath the shuttle. Why did that happen? Well, during the launch period, temperatures on the launch day actually dropped to historic lows, well into the below the freezing point. And they knew this. They knew temperatures were going to drop. And the engineering company that was responsible for the booster rockets, the engineers in the company tried to demonstrate that they shouldn't launch. And they forwarded several charts, several tables, several facts. You can see on the left-hand side, these are examples of what they had sent through, trying to convince management and also NASA not to launch. But ultimately, the management of the company decided to launch. You can see that they recommended there on the lower right to launch, even though they had all of this information coming from the engineers. So there was a disconnect. There was a failure in what the engineers were trying to explain and what was interpreted and what the final decision was for the launch. In hindsight, there was an investigative commission to understand what happened. How did they get to this decision? How did they go forward with this launch decision? So what they did in the commission is actually plot the data of several launches at different temperatures and the number of failures and number of incidents that they had on the solid rocket boosters. And you can see that first chart on the top is their first attempt. You can see that it looks like almost that there's no difference really in the number of incidents as you look across the range of temperatures. One of the things that they then followed up with is, well, look, you actually have to plot all of the launches, including the non failures or launches without incidents. And when you do that, you start to see in the bottom there a lot of zero incident cases. And that made it a little bit clearer that as you start to drop temperature, that you start to see an increase in incidents and failures in the solid rocket boosters. Still, the the commission didn't go far enough, because if you actually plot this out and show, the temperature range on the day of the launch, you see that it's exponentially, it's off the charts. So this is one example. This is, again, a story that kind of stuck with me in the importance of data visualization and using visualization to communicate, to influence, to persuade, to inform a better decision. So why visualize data? Well, a couple of statistics. We are visual animals. We actually can recognize images in as little as 13 milliseconds. There are estimates that 60% of the adult population are visual learners, so we learn through visual means. Some studies have shown that presentations and communications using visualization can be shortened by up to 24%. And you get an increased consensus, group consensus coming out of those meetings, maybe up to 20%. And finally, there's been studies that show that presentations using visual aids are 43% more persuasive than presentations not leveraging visual aids. So a lot of compelling reasons to get data visualization right, to get communication with data right. So I thought I'd share with you some of my experiences teaching data visualization. So the last several years, I've had the opportunity to actually teach a master's course or a graduate course in an MSBA program on data visualization. And I thought I'd share some things I learned from teaching. So to start, why do we care about teaching data visualization in a graduate level class? Well, it turns out that industry actually is hungry for this skill set. It's one of the top sought after skill sets in analyst roles in industry. So there's definitely a need for this in industry. It's something that is top of the list for most companies. So the class that I put together, the structure is roughly this. It's split up in two halves. The first half, I talk about the cognition processes. So the human brain, how do we perceive things, what gets our attention, etc. It's a fundamental understanding of how to communicate information. Then we talk about data preparation, and then visualization best practices. I want to share a few of those, but ultimately this is not a class. I want to kind of get to what are the key things that we should be thinking about in data visualization. There's also a second half of the class where we talk about storytelling and insights, slide craft, and an actual delivery of the presentation. So how do you actually get up in front of an audience and present? But actually there are tons of established thinking and content on data visualization, storytelling, communicating, etc. And most of this is done or produced by experts much better than I at this. So I'm not going to spend a lot of time going through all of the content in detail on how we actually should visualize data, but I do want to hit a few key points. Really, effective data communication isn't complicated. There are just some really basic things to keep in mind. So some of those are minimize ink, label clearly, make sure that you have the right font so it's legible, make sure you don't have insignificant figures, or make sure you check your significant figures on numbers. There should be a preference for substance in your content over the splash or bling. You have to make sure that you avoid bias, so tricks of scale in charts, selectively choosing certain data points versus other, etc. Generally, keep things as simple as possible and leverage rules around grouping and highlighting key data. And then key is using the right graph for the data that you have. So these are very basic things. It's not a advanced physics course that I teach. It's very fundamental kind of concepts. So, for example, Tufte's 5 laws of data Inc. Show the data above all else. maximize the data to ink ratio, so make sure that you have more data and less ink. Erase non-data ink, get rid of it. Erase any redundant data ink, and then revise and edit. And you can see kind of the before and after on the right-hand side of the same information, and really eliminating things that might distract us from what the data is telling us. And that's the idea on the high ink data ratio chart on the right. You also need to be aware of how we are attracted to certain visual stimuli. So basically, we're wired to notice differences. And so these pre-attentive processing cues, you should be aware of and leverage those when presenting or creating your visualization for communication. You can change form, width, orientation, the size. You can change the color, position. You can indicate motion. There are several things that you can leverage to create an effective visualization. And also, you should be aware of things to avoid that you might do to create bias or create the wrong view of the data. Beyond this, we're also wired to see to see continuity, and so this is what the Gestalt School of Philosophy really is talking about, and the Gestalt laws of grouping. So you can see a few examples here where things that are close to each other we assume to be in the same group. Things that are similar to each other we view as the same group. And enclosure is also an effective tool for grouping. And then symmetry. And then below we have examples where in our brain, where there are gaps in either figures or in, for example, the line on the lower left, our brain wants to have continuity. So we, by extension, create that association between the two pieces of the line there. And then we can also just directly connect data points via lines, for example, to create a grouping. So being aware of these laws of pre-attentive processing, Gestalt laws of grouping, help us make an effective visualization. Stephen Few is also another thought leader in the space. I'm leveraging some of his content here in this presentation. And one of his key points is to use the right graph for the data that you have. So if you've got categorical data with symmetrics, use a bar chart. If you've got time series data, use a line chart with a time series, for example. If you want to show correlation between two sets of data, use a scatter chart. So it's really about making sure you apply the right graph for the data that you have. And in teaching this course, it was interesting and enlightening to me to see how much of an opportunity there was in some cases for folks to really think through, what data do I have and how should I best represent that data? One thing you'll notice is there are no pie charts in this rubric for Stephen Few. He appears not to like pie charts, and I think this is a consistent kind of thinking from Tufte and other folks who are thought leaders in this space as well. And there's some reasons for that, but pie charts are probably overused, and whenever you have a pie chart, you can probably leverage a column or a bar chart. One of the key perception factors for that is that we are better at discerning differences in length than we are discerning differences in area. And a pie chart is basically an area graph, whereas a bar chart is showing you differences in length. Beyond that, it just creates a cleaner graph. You're able to, for example, sort the information from highest to lowest or lowest to highest, etc. So there are other things that you can do in the column or bar chart that enable you to make it easier for the viewer to understand what's going on in the chart. The other thing, this is a kind of a pet peeve of mine as well, is word clouds. And I've noticed, I haven't seen as many word clouds come up recently, but it seemed like for a good period there, word clouds were very popular, and you would see them in magazine articles, newspaper articles, etc., looking at social media data, other text content, etc., and they just are more of a fanciful kind of representation of data versus something that actually explains what's going on in the text. And I use this example in the class to show how you may not get the full meaning from the text that you might want if you use a word cloud. So I basically put the U.S. Declaration of Independence through an online word cloud generator, and the result is what you get on the left, and the things that kind of pop out as the largest and boldest text are states, laws, people, government. Yeah, those are elements of the Declaration of Independence, but the spirit of what was said is probably best captured in the first part of the Declaration of Independence, and that is the pursuit of life, liberty, and happiness. Right? That's something I think maybe we've all heard. If in first grade, probably, I think going as far back as first grade and learning what's in the Declaration of Independence, you wouldn't get that from the word cloud on the left. Another aspect is, again, keep it simple. This is don't bling your visuals, so keep your visuals as simple as possible. It's also this low ink principle. An example of this is on the left, there's a lot of kind of stylized features to the visuals, the graphs on the left. We've got 3D bar charts. We've got a lot of ink in the background and the shading. Things that can be simplified and reduced down to kind of highlight specifically things that we want to draw the attention of the audience to. So if you look at the right-hand side, they've reduced the 3D effects. They removed redundant lines, for example, on the column chart there in the top left. They've highlighted, for example, with color, the average line in the lower left as well, to draw your attention to that piece of the information. So just subtle cues, keeping it simple, reducing the bling, helps make a better visualization. So just some very basic tips and highlights of things that we talk about in the class and what makes a good visualization, right? It's, again, the point there is that it's not complicated. It's actually pretty basic kind of thinking. And so the question is, does everyone get an A in the class, right? If it's that easy, shouldn't everyone get an A? Well, unfortunately, the answer is no. Not everyone gets an A, and that was actually something that kind of surprised me to some extent. And why is that? Why is it that even though it's simple enough to understand what the rules are to create good visualization, that we still struggle, or we have folks who still struggle to make good visualizations? One of the issues is that reducing complexity is hard. And that's really the art of creating good visualizations. We have a lot of data, a lot of information, and it takes a lot of effort to reduce that information down into a clear, concise graphic or visualization that conveys the output or the content that we want it to convey. So Mark Twain had this quote that if you want me to give a 2-hour presentation, I'm ready today. So if you've got all the time in the world, you could probably be ready in a short amount of time. However, if you want me to give a 5-minute speech, it'll take me 2 weeks to prepare. And I can attest that that's actually very true. It took me a lot longer to prepare a 20-minute presentation. Hopefully I'll stay within the time limit than the entirety of the content that I have for the class that I would teach. And the other aspect to this is that just taking a class on data visualization or just knowing what makes a good visualization isn't enough. Best practices must be practiced. Malcolm Gladwell wrote in his book Outliers about this 10,000 hour rule, about becoming an expert in something. Now, in following up and reading recently on this, I know that there's some different views on this 10,000 hour rule, but the spirit is basically the same, which is you need to practice to get good at something. And this, I think, does apply specifically to creating good data visualizations. And so even though we had students in the class who understood what the best practices were, some of them probably didn't practice enough to get that A in the class. And that applies after the class as well. So it doesn't stop in the classroom. You actually need to continue working on the skill, making many different visualizations, making many different PowerPoint presentations. Whatever the communication is, you need to do it a lot to get good at it. And you should really be applying it to real world situations. As managers, I think we need to create opportunities for our teams to practice this. And it's something that I try to do in my teams that I've led, because it's a really key skill set, as we highlighted at the beginning of the talk today. Industry is seeking this skill set, and it's something that I think can really help in anyone's career, especially data science career paths, analytics career paths. Having the ability to communicate what you're doing and communicate it effectively will set you apart and really advantage your career. And then from a company perspective, I think companies really need to invest in a skill to realize the benefit of data visualization. As we saw earlier in the talk, a few slides back, that there are benefits to meeting efficiency, consensus building, and persuasion on key decisions. And one of the other things that I've noticed in the class, and why is it that we maybe still have some gaps in the ability to create good data visualization or communicate with data visualization, is I feel like there need to be coaches or mentors. So even beyond the classroom, either at a company, or if you're an individual, you should be practicing, but you should also find a coach or a mentor in this space, or find folks that can help you test your data visualization, your communication, to make sure that you're doing it well. And I think those coaches and mentors are key elements to creating good data visualization, effectively communicating as well. So that's all I have on this talk. I wanted to try and keep it within the time frame. I know we're late here. I'm going to pause. I guess I'll jump back over into the session, and I think there is a breakout room for Q&A. So I'll jump into that, and if anyone has any questions, I'll do my best to answer. So thank you again. Appreciate your time. Sorry again for the delays, and good luck with your data visualization.